Good morning or afternoon, guys. Today is January 7th or 8th, Thursday or Friday. Me and Mrs. Orland will be going over imaginary numbers and working on that to see if we can find the powers of I by dividing by 4. You're due now. You should pause it right now because I'm going to go over it in a minute. You're solving these 6 questions just by using any type of math that you know. You have to use a calculator, go for it, but try it by hand. You should have paused the video, so here is your answer key. Radicals 16, 25, and 36 are all perfect squares. They're perfect squares because I know the perfect squares, and I know that the little numbers that are hidden up here are 2. So what times what is 16? 4. What times what is 25? 5. What times what is 36? 6. Done. No thought at all on this. Next, we have -4 squared. -4 squared is like saying -4 times -4. A negative times a negative makes a positive, and a 4 times 4 makes a 16. Good to go. -5 times -5, or -5 squared. I don't need to see work. If you're smart and you know what you're doing, 25 is just your answer. There's going to be some type of connection between these two things today. That's why we're trying to show you that for today's Do Now. And -6 times -6 is 36. Those are your answers for the Do Now. No questions about that at all. If you have questions, pause the video or send us a message and we will help you out in a minute. So, now, simplify. Can't factor something out. We have never seen a radical with a negative inside of it. Not a big deal. We can factor something out and make our lives a lot easier. We know that radicals can't have negatives inside of it. So, we remember our radical rules. We can break down any radical into 2 radicals. So, since radical 16 is a perfect square, it's one of those special perfect squares, we're just going to write down radical 16. And radical 16 times what is negative radical 16? -1. This gives us radical 16 we just talked about is 4. Radical -1 is radical -1. It is not 1, because 1 times 1 is 1, not -1. So if that's your final answer, you're done with that for right now. So pause the video, see if you can figure out what radical -25 is, what radical -36 is. So, and welcome back. We should be figuring out what this is by doing the same idea as this. This is equal to radical 25. This is equal to radical -1. Multiply these, we come right back to where we were. Radical 25 breaks down to a 5, and radical -1 is still just radical -1. So you should just be able to look at this and say this is going to be radical 36 times radical -1. Radical 36 breaks down to 6, so we have 6 radical -1. Take it away, Mrs. Werling.
Yes, sir.
Maybe switch roles.
Well, let's see if it stays recording. All right, so what is the imaginary unit? Okay, this radical -1 is defined as the imaginary unit and is denoted by just the lowercase letter I. So an imaginary number whose square is negative is what the imaginary unit is. Where you see it is when you have a negative under the radical. So imaginary numbers occur when a quadratic equation has no roots at all in the set of real numbers. Meaning, well, if we were to graph this, the parent graph is x squared, and it's 1 being added to it, which means it's being shifted up 1 unit. So this is what the graph of x squared plus 1 looks like. Note, how many times does it touch the x-axis? 0, which means it has no real roots in the set of real numbers. No roots in the set of real numbers. So how can we solve this then, right? You can't factor it. If you want to, you can plug it into the quadratic formula, but who wants to do that? If you want to, you can do completing the square, but who wants to do that? So we're going to do it the old-fashioned way of just trying to get the x by itself. So we subtract 1 from each side. We get x squared is equal to -1. We don't want to solve for x squared. We want to solve for x. So in order to do that, we need to take the square root of both sides. So the square root of x squared is x. We have our radical -1, but remember, anytime you are solving a problem that has an x squared in it and you draw in a radical, you have to remember to put that plus or minus. So we get plus or minus radical -1. And we just define radical negative 1 as the imaginary unit. So we can write plus or minus I. That little lowercase I is the imaginary unit. So anytime we see radical negative 1, we use I. Or if we have a negative under the radical sign, we just use I, which you'll see in a minute. On this next page, where we have these 4 problems. Okay, we have radical negative 36. We've got 2 radical negative 49, etc., and 2 other ones that are down below. So simplify it the same way we simplified it. Well, we just did number 1, radical negative 36. We break it up into radical 36 and radical negative 1. The square root of 36 is 6. The square root of negative 1 is I, so this is just 6I. All right. Trick is anytime you see this negative, you can just pull it out and have it become an I. Okay. So for the second one, we've got 2 radical negative 49. All right. There's more than one way you can do this. It's true in all algebra. But if you want to circle that negative, and you can pull it out and make it an I. So it becomes 2I times radical positive 49 now, because we took that negative out and made it our imaginary unit. And the square root of 49 is just 7. So it's 2I times 7, which is 14I. All right, so pause it and see if you could do numbers 3 and 4. So pause it right now. Okay, we have negative 3 times radical negative 10. This negative comes out and becomes an I. So it's negative 3I radical 10. Can we simplify radical 10? Well, remember our perfect squares. We have 1 squared is 1, 2 squared is 4, 9, 16, 25, etc., etc. Right? The largest one of these numbers that goes evenly into 10 is just 1. So you can't simplify it. It just stays 10. So it's going to stay negative 3I radical 10. For number 4, we've got 5 times radical negative 8. Again, we're going to take that negative that's in the radical. We're going to pull it out and turn it into I. So you got 5I radical 8. And then we simplify the radical 8 just as we did in the radicals unit. Okay, we keep this 5I on the outside. We break up this radical 8 into radical 4 and radical 2. All right, the square root of 4 is equal to 2. So you get 5I times 2 radical 2, which becomes 10I radical 2. Okay, that's that. Going forward now, we've got to solve the following expression for x. So this is another example of when you would use the imaginary unit. We have x squared is equal to negative 3. Again, we're just going to take the square root of both sides, remembering when you put in the radical, you have to put the plus or minus. So it's x is plus or minus radical negative 3. We do not like the negative under the radical, so we must take care of that by pulling it out and turning it into an I. So this is going to be x is equal to plus or minus I radical 3. Okay? If you have any questions, please make sure you ask one of us. Okay? And then we'll get into the cyclic powers of I, which is right here.
Okay, the cyclic powers of I. Cyclic is a word that kind of means cycle or something that continuously repeats over and over again. Things of days of the week, hours in the clock, how much fun you have in there. We know that I is equal to negative radical 1. So let's think about some other things of I. I to the 0 power. Well, anything to the 0 power is equal to 1. Just think about it as anything divided by itself. It's the first power to the first power, such as like x divided by x. This is really saying x to the 1 power divided by x to the 1 power. This doesn't give you 0, this gives you 1. So anything to the 0 power equals 1. And that's just a general rule that you should know, and calculator could always help you. So let's keep going down. What's I to the first power equal to? I to the first power is itself. Anything that's raised to the power of 1 remains the same value. You have 238.234 to the first power is equal to 238.234. It's the same thing. Anything to the first power is just itself. So a weird thing like the letter I to the first power is still just another weird thing to the power of 1. So those are too easy, nothing, it's kind of a recap. But what happens when we get I squared? Well, I squared is the same thing as saying I times I. Well, we know that I is equal to negative radical 1. So negative radical 1 times negative radical 1. Let's see what that would look like. Negative radical 1 times negative radical 1 looks like this. Radical negative 1 times radical negative 1, or radical negative 1 times negative 1 would be radical 1. Keep squeezing down. And what does radical negative 1 equal? Well, 1 times 1 is 1, so radical 1 times radical 1 would just be radical 1, or 1. You need to remember this. Not the funnest thing in the world. Where did I put my negative? Oops, I put my negative up here. Oops. Well, you need to just remember, I is equal to negative radical 1, and I squared is equal to negative 1. It's just the rule you need to remember. It's just the way it is. Some things will never be the same. No. All right, so think about when this happens. It's all written right here for you. You just need to memorize this. Or use a calculator the school district bought you. So just keep that in mind. Let's keep going down our chart. I to the third power is equal to I times I times I, or radical negative 1 times radical negative 1 times radical negative 1. Well, if we do this, we just talked about what happens here. It brings I squared. I squared is negative 1. Negative 1 times I would be negative I. And the pattern continues. 0 power is 1. First power is I. Second power is a negative I squared. Okay, and our last one, I to the fourth power, is I times I times I times I, which is I squared times I squared, which is negative 1 times negative 1. What's negative 1 times negative 1? Just 1. And that's just something you need to remember as well. But there's a chart that's going to help you with this. Notice that the fourth power is the same as the 0 power. I to the fourth equals I to the 0 power. Well, if you added 1 to these, I to the fifth is going to be equal to I to the first. If you added another one, I to the sixth is equal to I to the second power. I to the seventh would be I to the third power. I to the fourth would already be up here. So this is what we're talking about, a cyclical cycle. It just follows the same pattern over and over and over again. And this is the pattern. I to the first, second, third, fourth. First or fifth, second or sixth, third or fourth, third or seventh, or fourth and eighth. Anytime it's a multiple of 4, it's going to just equal 1. That's a really good starting point to kind of memorize the chart for. But with this, we're going to find a really nice trick in the calculator. But I do want you to know what the pattern is. If we continue this out, we would go I9, I10, I11, I12, I13, I14, I15, I16, I17. Hopefully you're getting the pattern here. It goes on forever. And someone's thinking right now, why am I going to memorize this? I'll just do this out on my own. Till the Regents gives you this question. I have the 426 power. Are you going to spend the hour and a half writing this chart out or memorizing a small, easy pattern? The way to memorize the pattern is either use the calculator to help you or you remember what the remainders are. And the remainders are, I think, the easiest way to remember these. You are going to take whatever number we have, the power, and divide it by 4. And write down what you get as a remainder or a decimal. 1 divided by 4 is 0.25. 2 divided by 4 is 0.5. 3 divided by 4 is 0.75. And 4 divided by 4 is 1.0. If you take any power and divide it by 4, these are the ways to memorize it. If it's got a 0.25 as a remainder, your answer is I. A 0.5 as a remainder, the answer is -1. A 0.75 as a remainder, -1, or a 1 or a 0 as a remainder, it would just be that. So take a second. 462. Plug that in your calculator. 462 will have a remainder of a point something something. From there, you're going to do 426, and divide it by 4 and see what you get as your remainder. And that will tell you your answer. I got 62 divided by 4. I get 106.25. 0.5 on our list. -1. That's the way the Regents are probably going to ask you the question. Something like this. If it's a part 2, just write down the answer. If it's a part 1, obviously circle the correct answer. But our calculators are really, really, really smart. No. Everything go away. There we go. Okay. Say that you had... Okay, whatever. The letter I is right here. Plug in 2, 4, 26. There's an error. Why is there an error? I picked the letter I. This is not the letter I. This is like the letter I in the English alphabet. Your calculator is not that smart sometimes. Your calculator is actually way dumber than you think. Your calculator wants you to use the symbol I. Really? Want something else? Thank you. There you go. There you go. All right. Sweet. This is working wonderfully. This letter I. If you press the pi button right here and just go to the letter I, you can type in any number that you want to the power of. There you go. So that's the majority of everything we need to go over for today. So take a second. Oh, this is the power of I. Just explain it another way. You can continue this pattern forever and ever and ever. I'm not going to go over it because I already went over it, but it just goes in a big circle on and on and on. So you guys are going to pause. We'll do number 1 together. Then we're going to pause the video and you guys will finish this out. Yep. All right. Simplify 3i squared. Well, 3i squared is like saying 3i times 3i. If this was the letter X, you would all get the right answer. But because this is the letter I, we're all going to freak out and say we have no idea what we're doing. So let's go nice and slow. 3 times 3 is 9. I times I, or like X times X, would be something squared. Okay? You're done except 1 point deduction because I squared is equal to what? I realize no one's live, so no one's going to answer that. 9 times -1, because I squared is equal to -1, -9. Hey, pause your video. You got 5 questions right here. We'll go over these. Mrs. Roll and finish up the lesson in a minute. We'll do these, and then you'll do the next page. Okay, hopefully you took about 5 minutes to look these over. 4i squared is 4i times 4i. 16i squared. I squared is defined as -1, so it's going to be -16. Same thing. I'm not going to go step by step. It's getting easier. We're distributing technically using the power rule. 25i squared minus a point, because this is bad. I squared is not a number. It's an imaginary made-up thing. -25. A little bit trickier. I radical 6. So let's write it out. I times radical 6 times I radical 6. Like terms. I times I is I squared. Like terms. 6 times 6. With a radical would be 36. I squared is -1 times 36 is just 6. Kind of looks familiar from the other guys, just working backwards a little bit. This guy is going to be I squared. Radical 11 times 11 is 121. -1 times 11 equals -11. Anytime you're squaring a radical, this is technically a square, these cancel. That's why they get it coming out so quickly and easily. Mrs. Well, to finish this up, I believe this is the last page. Then we got a few easy ones at the end.
Couple more. Yeah. All right, so when raising I to any integral power, the answer is always going to be I, -1, -I, or 1. This is our cyclic nature of I. We have I to the 0 up top, that's equal to 1. As we go around in a counterclockwise fashion, I to the 0 is 1, I to the first power is I squared is -1, I to the third power is I to the fourth power, and then back at the beginning. So I to the fourth power is 1, and we keep going around and around and around. That's how you can see what happens. So this one is all about the calculator if you can't simplify it. All right, I to the 6th power. You can go around your circle 6 times, 1, 2, 3, 4, 5, and 6, and see where you land. And see where you land. So sorry, we start at 0. So we start out of the 1st power, 2nd power, 3rd power, 4th power, 5th power, and 6th power. When we get I to the 6th power, it reduces down to I squared, which is just equal to -1. Similarly, you can plug this into your calculator, right? And as Mr. Fallot said, we take our exponent, which is 6, divide it by 4, and you're going to get a 3/2. If we control enter this on the calculator, it will convert that to a decimal. You'll see we are a 0.5, which, as he explained before, 0.5 matches up with the I squared. Or with these fancy calculators, if we press the pi button, you go to I, we raise that to the 6th power, and it will just tell us it's equal to -1. Okay, so that one's going to be equal to -1. I to the 9th power, again, we just plug that in. We have I to the 9th power, and it'll tell us that that is equal to I. Okay, so plug these in your calculator, and you will get your answer. Okay, this is just what we were explaining before about using a calculator, dividing it by 4, and get the remainder. But what's nice is with these new calculators, which so many of you still have to pick up, you'll see it can do it for you right away. Okay. So again, simplify I to the 35th power. All right. We're not going to sit and go around that wheel or use that chart all the way to the 35th power. All right. We just type in I to the 35th in our calculator. So I to the power of 35. You press enter, and it's equal to -I. It's that straightforward, that easy. Okay. What about this one? I to the 12th plus I to the 14th plus I to the 20th minus I to the 6th. Pause it, take a minute, simplify them, and see what you can get this down to. All right, I to the 12th power, if you plug that in your calculator, it will be equal to I to the power of 0, which is equal to 1. Right, plus I to the 14th power is going to simplify down to I squared, which is -1. Put that in parentheses. Okay. I to the 20th power is also going to simplify to I to the 0 power, which is 1. And I to the 6th power, again, is going to simplify down to I squared, which is -1. So it's minus -1. All right, and then just simplifying. 1 plus -1, well, that's going to cancel out. Those are going to go away. And then we have 1 minus -1, which is just 1 plus 1, which is 2. So there's your answer, okay? Or you could have just plugged this all in your calculator at once. And I to the 12th plus I to the 14th, et cetera, equals that, okay?
Looks just like this, guys. So I have to go over that again.
Yeah.
Okay.
All right, product, same thing. Just type this in your calculator. I to the 8th times 2I squared times 4I to the 10th. So we plug this in. I to the 8th power times, what was it, 2I.
I got a little exponent still.
Oh, thanks. Times 2I to the, I think it was the 4th, I don't remember. 2I to the squared. So 2I squared times I to the 10th.
No, 4.
4I to the 10th. I lied. 4I to the 10th. 4I to the 10th. Enter, and it just spits out an answer of 8. Okay? So if you have any questions, please let us know. All right? Ask your teacher. If you have me, ask me. If you have Mr. Fallon, ask him. We will clarify anything we have for you. And if that's it, then have a good day.
Hey, guys. See you next day or two.